Hello, my name is Gopala Vasudevan. Today we will talk about Chapter 5. Chapter 5 deals with the production process and cost. So what are some of the things we want to talk about today? So if you are a corporation or if you're an enterprise, you have to make decisions for the short term and you also have to make decisions for the long term. So as far as this chapter is concerned, what we typically assume is that in the short run, the capital is fixed. So there are two inputs we want to look for. One is the capital. This talks about the investments a company has to make or a corporation has to make, and the other one is the labor. So what we typically assume is that in the short run, the capital is fixed, the labor you can change. In the long run, you can change both labor and capital. We will talk about the measures of productivity, and we will also talk about the manager's role in the production process. We will talk about at least three different forms of the production function. We will talk about isoquants and isocost, and cost minimization and optimal input substitution. We will talk about the short-run cost, what is meant by average and marginal cost, relation among these costs, and perhaps something that's very important is we will talk about fixed and sunk cost. Now these may not be important from an examination point of view, but typically for a corporation, especially when you try to do some capital budgeting and some forecasting and so on, we really have to distinguish between fixed and sunk cost. Okay, we'll deal with more with that later. We will talk about the algebraic forms of cost functions and long-run cost and economies of scale. And finally, we will talk about multiple output cost functions. So in chapter 4, this talked about the consumer's point of view, and we talked about how consumption changes, decisions change with response to price and income changes. So we developed and illustrated the underlying principles of individual and market demand curve. So there we were mainly talking about the individual point of view or from the consumer's point of view. Now here we are talking about the firm's point of view, and here we are talking about how managers select the optimal mix of inputs that minimize the production cost. So there what we try to do is that our objective is to minimize the production cost, and how do we choose the optimal mix of, in this case, labor and capital that can minimize the production cost. So let's look at a production function. So what is a production function? That is a mathematical function that defines the maximum amount of output that can be produced with a given set of inputs. So here Q is the level of output, and what we are saying is that it depends upon two things. It depends upon the quantity of capital input, and it depends upon the quantity of labor input. So the main two inputs are capital and labor, and we are talking about a production function that depends upon these two factors. Now in the short run, what do we assume here? We assume that in the short run, some of the factors of production are fixed and constrain a manager's decisions. Primarily here we are assuming that capital is fixed. So basically what that means is that for a corporation you cannot change. For example, you're a hospital, you have a particular building, and that building has a particular set of number of beds. It's very difficult to increase the number of beds in the short run, but in the long run we are saying that you can increase the number of beds, and you can also increase the number of physicians and so on. So here in the short run what we are saying is that we can do something about the labor input, but we cannot do anything about the capital input. Now when you talk about productivity, what are the different measures of productivity? So here the total product is the overall output or the maximum level of output that can be produced with a given set of inputs. Okay, so we are assuming that the inputs are fixed, and given that, what is the most we can produce? Now we want to talk about the average product, and what is the average product of labor? That is given by the quantity produced divided by the labor used, and average product of capital is the quantity produced divided by the capital used. Now what about the marginal product of labor? The marginal product of labor is the change in total output attributed to the last unit of an input. So given that we're going to have one more unit of labor, what is going to be the change in the output? Or basically here what we are doing here is that we are talking about the derivative of the output with reference to the derivative of the labor. So that is delta Q over delta L. So what is the increase in the output or the decrease in the output for a given change in the labor? And marginal product of capital is the delta Q over delta K, or that is the change in the output for a given change in the capital. So if you increase capital by 1 unit, by how much is the output going to change? And if you increase the labor by 1 unit, how much is the output going to change? So that is the marginal product of labor and the marginal product of capital. So let's look at an example. Okay, consider the following production function when 5 units of labor and 10 units of capital are combined to produce 150. So the output is 150, and what we have is 5 units of labor and 10 units of capital. So what is the average product of labor? The average product of labor is the 150, the output, divided by 5. That gives you 30 units per worker. What is the average product of capital? That would be 150 by 10, which is the 15 units. Okay. So here what we have is, it tells you the relation between productivity measures in action. So what we are saying is that initially, as we increase the labor, the output is going to increase, and after that, after a certain point, it's not going to increase. Actually, the change in the output for a given change in labor, that starts going down. So there, it's not negative, but it is not as much as before, and after some time, increase the labor more is not going to help. So there we will have negative marginal returns to labor. So that's what we see, the 3 portions. The first is that as you increase the labor, it's going to help the output dramatically, but after that the dramatic increase is no longer there. It starts slowing down, and then it again starts becoming negative. So that is the marginal product of labor. Okay, and here we have the total product, average product, and the marginal product. Now, what is the manager's role in the production process? So how can a manager change the production, change the outputs in the production process? So basically here, produce output on the production function, aligning incentives to induce maximum worker effort. So basically here, what we are saying is that the manager should do those things that will basically motivate the employees to do the most for the company. So how can you do that? So some of the ways are providing a bonus, providing some other rewards as they increase the output. Use the right mix of inputs to maximize profits. So to maximize profit when labor or capital win in the short run, the manager will hire labor until the value of the marginal product of labor equals the wage rate. So what we are saying here is that the wage rate, that is how much the employee is getting paid, and we want to make sure that they should be, we want to hire as many number of people so that the value of the marginal product of labor is equal to the wage rate. And what is that? The value of the marginal product of labor is given by the price times the marginal product of labor. So P times marginal product of labor, and capital until the value of the marginal product of capital equals the rental rate. So basically here, we are saying that we want to invest till the point where the marginal product of capital equals the rental rate, or the value of the marginal product of capital is equal to R, okay, where R is the rental rate. And VMPK is given by P times the marginal product of capital. So we have P times the marginal product of labor and P times the marginal product of capital. So let's look at an example here. Suppose a firm sells its output in a competitive market where the output is sold at $5 per unit. If workers are also hired at a competitive wage of 200, what is the marginal productivity of the last worker? Value of the marginal productivity is equal to the wage rate. So in this case, the value of the marginal product of labor is given by $5 is the output price times the marginal product of labor, and here the wage is 200. So 5 times the marginal product labor is equal to 200, and the marginal product of labor is going to be 40 units. Okay, so that's basically what we are saying here, and how we can figure out the till when should he be hiring. Okay, So what we are assuming here is that the firm sells its output in a commodity market where the output is sold at $5 per unit and the commodity wage is 200. Okay, so what we are saying here is that you want to hire till the point where the marginal product of labor is equal to $5, that is the output price, times the marginal product of labor. Okay, and here W is 200. So basically here the wage is 200, so that gives you the 40 units. Now, what are the different forms of production functions? So the first one is a linear production function. So there, what we are saying here is that the production function is given by FKL, which is equal to A times K plus B times L. So A and B are constant. So what we are saying here is that as we increase either one, either that could be capital or that could be labor, we will find that an increase in the number of the output. Okay. Now the second one is Leontief function, and in the case of the Leontief function, the output is given by minimum of AKBL, where A and B are constant. So basically here what we are assuming here is that we should not be increasing one variable much more than the other, because what really matters is the output is dependent upon the minimum of these two variables. So one variable will definitely influence the other. So here what we are saying is that capital, the amount of capital we have will influence the output. Okay, even if you increase the labor much more. Okay, the third one is the Cobb-Douglas function, and in this case what we have is that Q is given by the output is given by K raised to A L raised to B. Here K stands for the capital and L stands for the labor, and A and B are constants. So let's look at these examples. Okay, algebraic forms of production functions in action. Suppose that a firm's estimated production function is given by Q equals 3K plus 6L. How much output is produced when 3 units of capital and 7 units of labor are employed? So basically here all that we are doing here is, for this production function, we are substituting the amount of capital and the amount of labor. So 3 is the constant, K here is 3 also, 6 is the constant for labor, and the amount of labor is 7. So that gives you an output of 51 units. Okay. Now let's look at the algebraic measures of productivity. So for the linear function, that is FKL is given by AK plus BL, where A and B are constant. Now what is the marginal product of capital and what is the marginal product of labor? So marginal product of capital is given by DQ divided by DK, and that gives you A, and the marginal product of labor is given by DQ divided by DL, that gives you B. And what about the average product? That is all that we are doing here is that taking the production function and dividing it by the capital, and the average product of labor is again dividing by the labor. Now for the Cobb-Douglas function, that is given by FKL is given by K raised to A L raised to B, where A and B are constant. So how do we find out the marginal product? So that would be dq divided by dk. We are taking the derivative of q with reference to the capital, and that gives you a k a raised to minus 1 l raised to b. So if you're not comfortable with this, you want to go back and see how to do the derivatives. Okay, so we are taking the derivative of the quantity dq with reference to the dk, and to do this, basically that would be a is the exponent of k, and then a k a raised to minus 1 l raised to b, and the marginal product of labor is given by b k. Okay, so the marginal product of labor is given by b k raised to a l raised to b minus 1. Yeah, and average product is given by k a raised to a l raised to b, okay, divided by the k. Okay, so all that we are doing here is that the quantity divided by the amount of capital, and the labor again we are taking the quantity divided by the labor. Okay. So let's look at an example. Suppose that a firm produces output according to the production function F1L is given by 1 raised to 1 by 4 L raised to 3 by 4, which is a fixed input. So basically here what we are assuming here is that the capital is fixed. Okay. And what is the marginal amount of labor when 16 units of labor is hired? So basically here we are taking dq divided by the derivative of dq to dl, and that gives you 3 by 4th L raised to 3 by 4 minus 1. Okay, so that gives you 3 by 4 L raised to minus 1 by 4, and here for 16 units of labor the answer you get here is 3 by 8. Okay. Now we also want to talk about the isoquants and the marginal rate of technical substitution. So isoquants capture the trade-off between combinations of inputs that yield the same output in the long run when all inputs are variables. So what we are assuming here is that the output is fixed, but we are looking at the trade-off between capital and labor. And marginal rate of technical substitution, that tells you the rate at which a producer can substitute between two inputs and maintain the same level of output. So what we are saying here is that suppose we want to change labor for capital, how much units of capital do we need to supply to replace 1 unit of labor? That's an example. Okay, and absolute value of the slope of the isoquant is given by the marginal rate of technical substitution is given by the marginal MPL divided by MPK. That is the marginal product of labor to the marginal product of capital. Okay, so this is what we see, the isoquants and marginal rate of technical substitution. So what we see here is that the initial curve is Q1 equals 100 units of output. So for 100 units of output, what is the combination of capital and labor that we want to use? Q2 equals 200 units of outputs. So what we are saying is that all points on this line, they have the same output. What is changing here is that the amount of capital and the amount of labor. So as we go down, we are having more labor and we are using less capital, and as we go up, we are using more capital and less labor. Okay. Now let's look at this example. So here, diminishing marginal rate of technical substitution. So delta K over delta L, in this case that would be minus 3, and delta K over delta L at this point is minus 1. Okay, so that's what we see here regarding the marginal rate of technical substitution. Okay. Now what is an isocost? An isocost is a combination of inputs that yield the same cost. So let's look at this example here. We are assuming that WL, so the wages times the labor plus R times K, the rental rate times the capital, is equal to C. Now if you want to change things, move things around, what is the amount of capital here? That is given by C divided by R. So that is the rental rate minus W by R times L. So here this tells you the isocost line. Okay, and we can figure out the changes in the outcost. So in the isocost, so for given input prices, isocosts further from the origin are associated with higher cost. That's what we saw in the previous PowerPoint slide. Okay, and changes in input prices change the slopes of the isocost line. So this is what we see when we look at the isocost line. So we have the capital input that is given by C by R, and the labor where the intercepts that is given by C by W. That's what we derived earlier. And what we see here is that the less expensive input bundle is the first one, and as we move further away, we will find that we have more expensive input bundles. Now it also tells you the changes in the isocost line due to increase in the wage rate, and this is what we see here, C by Wn. So W1 is greater than the W0. So as the wage, this tells you the lines. And ideally, what should be the cost minimizing input rule? So the cost minimizing input rule is the point where the marginal rate of technical substitution is equal to W by R. So that is the wage divided by the rental rate. Okay. And if you look at this, what is the cost minimization and the cost minimization input rule? So the cost minimization means producing at the lowest possible cost, and cost minimizing input rule says that the marginal product of labor divided by the wage should be equal to the marginal product of capital divided by the rental rate. So what that tells you is that the marginal product per dollar spent is equal for all inputs, and the two inputs we have here are labor and we have the capital. Equivalently, a firm should employ inputs such that the marginal rate of technical substitution equals the ratio of inputs prices. So if you want to look at the marginal rate of technical substitution, that is the marginal product of labor divided by the marginal product of capital, and that should be equal to the wage rate divided by the rental rate. Okay. Now let's look at another example. Suppose that labor and capital are hired at a competitive wage of 10 and 25 respectively. If the marginal product of capital is 6 units and the marginal product of labor is 3 units, is the firm hiring the cost minimizing units of labor and capital? So basically what we said was the marginal product of labor divided by the marginal product of capital should be equal to W by R. Now do we see that? So here the marginal product of labor divided by the wage, that is 3 divided by 10, and the marginal product of capital is 6 divided by 25. So what we see here is that the marginal product of labor divided by the wage is higher than the marginal product of capital divided by the rent. So basically here the firm is not minimizing the cost and should use fewer units of capital and more unit of labor. And the reason being that the marginal product of labor divided by the wage rate seems to be higher than the marginal product of capital divided by the rental rate. So this tells you the optimal input substitution in action. So basically here this is the cost minimizing point due to higher wage, and this tells you the initial point of cost minimization. So basically here we are moving to a point where we are using more labor